Hello, good morning, and welcome to our presentation on building an enhanced oral imaging and automated diagnosis tool. In dentistry, delivering remote diagnosis is virtually impossible. A large part of the population still finds basic dental care inaccessible, particularly in remote parts of the world, and more so during the pandemic. Even when accessible, we often ignore regular checkups. Our solution to this proposes using snake cameras that our users will put in their mouth to generate a scan. Our computer vision algorithm will take continuous video feed coming from the camera and get position and depth information using well-known techniques in machine learning and robotic vision. And it will generate a 3D model of the mouth and overlay the images on it to get an enhanced visual. This you would be able to send to a doctor or use as a part of our ML pipeline to get automated diagnoses. We need good imaging in the first place to be able to stitch together a good 3D model. To do this, we propose making a phone app which will keep getting data live from the imaging being done by our user, and the app will keep telling which parts of the mouth the user needs to try and scan further. This would be on similar lines as registering a fingerprint on your phone, which tells you which parts of the finger you still need to scan. Sending scans to your doctor and getting automated diagnosis will be a part of the same app. Giving a nice 3D model with color information, we will use graph neural networks to identify issues on the teeth like caries, cavities, etc. Most of these are easy to detect with high quality images.
To train our imaging and landmark system, we have put together a Blender environment which can render accurate images with respect to the lighting and field of view conditions as observed from a mouth cam. Using the plugin Blender for Dental, we will simulate caries and cavities.
Now let's dive deeper into the low-level details of our pipeline. Bundle adjustment will be used to generate 3D point clouds from 2D images taken from known positions, and we can compute those positions from visual odometry. This is in general a very hard problem to create 3D point cloud from 2D images, but we have algorithms to segment images of the teeth and identify key points on them, and this will greatly facilitate our solution. The cost of the size of depth camera necessitates using a purely visual-based solution. Every time the same part of the mouth gets imaged, we have a loop closure algorithm to help reduce the noise of that portion in our point cloud. There are existing oral image segmentation algorithms like MCNet, which will help us to estimate the true position of our camera. To do the key point detection and figure out which plane of which tooth is being imaged, we will be training various algorithms from our Blender dataset.
Now let us look at the tech and market specifics. We thank Azure for providing free credits to us so that we can build our solutions reliably. We will click several RGB images and then stitch them together using Azure Cloud ML pipelines. We will also use Azure Mobile App Services to provide rich backend processing functionality to our mobile app users. We have four broad modules in our solution. First, our users take a video feed of their mouth. The cloud processing unit stitches them together. The ML framework generates diagnostic results. This pushes the generated scans back to the phone app, and then Blender is used to generate the initial training dataset. Hopefully, over time, we will get a crowdsourced dental dataset on our app to refine our model as well.
Our plan of action is divided into 4 sprints. The first one consists of setting up 2D to 3D reconstruction algorithm tested on Blender model dataset. Secondly, we'll be building the entire software framework and application. The third sprint involves testing our performance using actual snake camera, and the final and fourth sprint would be to train and evaluate models for anomaly detection and suggested diagnosis. Our hardware is low cost and simple, making it easy to take it to the market. Up to 60% of the population today suffers from dental anxiety. This fear of going to the dentist should not come into the way of your dental hygiene. We hope that our device can be a part of every home, save everyone a lot of pain, and we'll be able to set these up in rural booths as well for helping people at large. The data accumulated can also facilitate dental emergencies.